Good morning, this is the Math 300 test review for test number 1, and I'll be going over the review sheet, which looks like this. I'm going to hit some of the key problems, the ones that I think maybe are a little more important, and if anyone shows up, I'll take any special requests. So I'm going to start with number 1. It's a fairly easy one. You're given a system of equations, and you're asked if a given ordered pair is a solution. And I'm going to do part B because it's a little more interesting than part A. So let me copy that down. So we have 2x minus y equal 10 and negative x plus 3y equal 9. And then the point that we're checking is 3, negative 4. The way you can tell if this is a solution is you take the value of x and y that you're given. So here the x value that we're given is 3, and the y value is minus 4. And we stick that into the system and see what happens. If both equations are true, then it is a solution. If one or both is false, it's not. So if you put in the 3 for the x in the first equation, it becomes 2 times 3 minus, and you got to watch the sign here, minus the y, which itself is negative, so minus minus 4. And then that's supposed to be 10. And if you check that one, so let's just rewrite this. It says 6 minus minus is the same as plus. So 6 plus 4 is 10. So that says 10 is 10. And that is true. So far so good. So far it does look like we have a solution. But we have to check the other one as well. We have to check the second equation. So stick in the x of 3. Now there's a minus in front of the x. So it'd be minus from the equation. The x itself is 3 plus triple the y, which remember has a negative, so negative 4. And that's supposed to equal 9. So let's see what this says. You have negative 3, and then the 3 times minus 4, you could write that as minus 12, equals 9. I don't even have to simplify. Clearly that's not true. This is false. If one or both equations is false, it is not a solution. So it looked like it was at first, but it's not. So this is something you can do at the end of problems to check and see if your answer is right or not. For number 2, I'm going to do all 3 parts because all 3 parts are kind of important. We're going to solve by first substitution, then we'll use the graphical method, and then we'll use the addition. It's also called addition elimination method. So let's start with part A. So 2a, 4x plus 12y equals 4, and negative 5x plus y is 11. And we're solving this, and for this part it's by substitution. Substitution would always work, but it's not always the best choice. With these problems, you want to kind of play it by ear. Some work real well with substitution. Others work really well with addition elimination. Graphical is often a good way just to get a feel for the problem. It's often not a good way to get an exact answer. For this one, substitution is not a bad idea because notice I can take this bottom equation and I can pretty easily solve that for one of the letters. That's one of the keys that tells you this might be a good idea. If either equation can be easily solved for either letter, it might be worth trying. So I can easily solve this bottom one for y. Just have to add 5x to both sides of it. So you could rewrite this bottom one. On the left it's going to be y, because I got rid of that 5x. And on the right, you have 5x plus 11. And this will be a factor we're going to come back to later. And then you substitute what we just found out about y. You're going to plug this into the top equation. So the top equation says 4x plus 12 times y, but now I know what y is. Y is 5x plus 11. So I'm plugging in, replacing, substituting for the y, what we learned from equation 2. And then we're down to just one letter, so it's a lot easier to do. We'll distribute, and then if necessary, collect terms, etc. So distribute, you have 4x plus 12 times 5 is 60, so that's 60x. And then 12 times 11 is 132. And then you have a couple like terms. You can add the 4 and the 60x together to get 64x. Plus 132 is 4. I want to isolate the x term, so I'm going to subtract 132 from both sides. And then the left side is just going to be 64x. Right side is minus 128. And now we're close, at least for the x. Since we want the x by itself and it's multiplied by 64, just divide by 64. Divide the left by 64, you just get x. Let's skip a step. Divide the right by 64, you get minus 2. So we figured out the x. And then to find the corresponding y, you go back up to this fact we got earlier. It says the y value is 5 times the x value, which I now know is minus 2, plus 11. So y is negative 10 plus 11. So y is 1. Then the answer is an ordered pair. It would be the ordered pair minus 2, 1. And I can check this just like I did in problem 1. I can go back to my system, plug in x equals negative 2, plug in y equal 1, verify that both equations are true. For example, in the top one, you'll have minus 8 plus 12 equal 4. That's right. And if you plug into the bottom one, you'll see that's true as well. B, that's going to be a little trickier to do because it's graphing. So I'm going to be using a computer program that's kind of nice for this. But let me first copy it. And some of the work I'll do here, but some I'll do on the computer itself. So B, 7x minus 2y is 20. The other one is negative 2x minus 4y equals 8. These are both lines. They're both linear. You don't see any squares or cubes or anything like that on the variables. It's just number times x plus number times y equal number. So graphically they're lines. And what I try to do with lines, if I can, is to try to get intercepts. You don't always have 2 intercepts. Sometimes you just have 1. But if I can get 2 clean intercepts, that's usually the easiest way to get the graph. So let's start with the bottom one because it's simpler. To get a y-intercept, to find out where the line hits the y-axis, let the opposite of the letter x be 0. Because you're going to be on the y-axis when x is 0. When x is positive, you're to the right. When x is negative, you're to the left. When x is 0, you're right on the y-axis. So you stick that into the bottom equation. It's going to knock out this first term because it's minus twice 0. And that just leaves minus 4y equal 8. And then divide by minus 4. And you get that it hits y at minus 2, which is going to be down here somewhere. I guess I'll do this more precise in a second. Then to get the x-intercept for this bottom equation, let y be 0. It's always the opposite letter. For x-intercept, let y be 0. For y-intercept, let x be 0. Because if y is positive, you're above the x-axis. When y is negative, you're below. When y is 0, you're right on it. Stick that in back here into that second equation. It kills the y term. You have minus 2x equals 8. and then divide by -2. And so you're hitting x at -4, which is over here somewhere. And then you'll just be connecting those dots and you'll get your line. So the first graph will be something like this. Given my setup, I just can't do this precisely. I can't use a straight edge. That's why I'm going to have to do this more precisely on the computer. The other one's a little trickier. You can do the same thing. You can do the intercepts. And the y-intercept's not bad. If you let x be 0, it's going to knock out that first term. You'll have -2y equals 20. Divide by -2, y is -10. So that one's down here somewhere. What's a little bit trickier is if you try to do y equals 0 to get the x-intercept. If you knock this term out, then your x is kind of messy. I mean, it's okay. You get 20 divided by 7, which is roughly 3. So it'll be over there somewhere. But it's a little messy. Your other option is to, instead of trying to find an intercept, just pick some random point. Just plug in any random number for x, or plug in any random number for y. It doesn't matter. And then just solve for the other letter. Sometimes that's a better idea. I'm not going to worry about it, but get 2 points however you want to get it. You get this other line. And then when you're solving graphically, what you're trying to find is where do these two cross each other? And so the solution will be the position of that point right there. So let's do this more carefully. I'm going to go to a website called desmos.com. And it's a really nice, easy to use, kind of pretty tool that you can use. And I can just type it in as it was given, 7x minus 2y equals 20. And it draws that first line. And notice those intercepts, the -10 that I figured out earlier. That was back up here in red. And then the other one was the kind of messy thing that was roughly 3. That's right there. And so that's this line that we're seeing over here. Sorry, that's why I'm not doing this on this particular application. So that's that line right there. And then the other one is -2x minus 4y equals 8. This is the one that was easy to graph. You have a y-intercept at -2 and an x of -4. So x of -4, y of -2, that's this other line over here. And then when you're solving, you're trying to find all the ordered pairs that have been shaded twice. You want to find where they come together. And on Desmos, you can see that's 2, -3. So the black line is all the ordered pairs that make the second equation true. The purple line is all the ordered pairs that make the first equation true. You're trying to find points that make both true. So you're looking for points that have been basically colored in twice. And there's only one point like that, and that's 2, -3. So that's the solution. This point here, if you draw this correctly, is 2, -3. And you can check. If you stick in x equals 2, stick in y equals -3, they should both be true. For example, in the top one, you'll get 14 plus 6 is 20. That's true. In the bottom, when you get -6 plus 12 is 8, that's true. This is definitely right. Trouble with the graphical method is you have to be really, really careful and precise to get the answer. As you see, I was not here. I could get a rough idea what it was, but I have to be more precise like this to really nail it down. Okay, and then the third one we're going to do with addition elimination. So let me copy that. Sometimes this will be the easiest method. Sometimes it's not. It just depends. So C -3x plus 7y equals -2, 4x minus 5y equals 8. We're doing the addition elimination method. The idea here is you want to try to modify, if necessary, one or both of the equations. So either the x terms or the y terms are either exactly the same, or normally I prefer making them exactly opposite. That's usually a little bit easier. So you have some options. You can do this lots of ways, but I'm going to try to make my x terms exact opposite. I want to make this and this exact opposite. And so to make that happen here, I'm going to take this top equation and multiply both sides by 4. Because that's going to turn this first term into a negative 12x. And I'm going to take my second equation and multiply both sides by 3. Okay, I'm picking whatever it takes to make the x's be opposite. If I multiply the top one by 4, I get negative 12x. If I multiply the bottom one by 3, I get plus 12x. Just do whatever it takes. So if you do that, the top one, if you quadruple everything, is minus 12x plus 28y equals minus 8. And the second one, if you triple everything, is 12x minus 15y equals 24. And then if you add these equations together, notice what happens to the x's. You have negative 12x's, you're adding plus 12x's, you get no x's. The x's are gone. And that's the point. That was the goal. There's 28y's, take away 15y's, that'd be a total of 13y's. And there's a 24 and a minus 8, that'd be 16. Now we're down to just one letter, just y, so it's easy to solve this. Just divide both sides by the 13, and that'll make this y be a plain y instead of a 13y. So the left will be y, the right will be 16 over 13. So the y is figured out, and then to get the x, you plug into anything. You can plug into the original top equation, you can plug into the original bottom equation, you can plug into the modified top equation, you can plug into the modified bottom. It doesn't matter. Do whatever looks easiest. And nothing looks overly easy, but I think I'll plug into this. So take that value you just found and stick it into that equation. So now it says 4x minus 5 times the y, which is 16 over 13, equals 8. So 4x minus the 5 times the 16, that'd be 80 on the top, and then still 13 on the bottom. If it helps, you can put the 5 over 1, so they're both fractions. And then you just multiply the tops, get the top. Multiply the bottoms, get the bottom. Right side is 8, and then we're trying to get to the x. So first add 80 over 13 to both sides. So the left will be just the 4x. And then you want to probably put the 8 over 13. So you multiply 8 and 13, which is 104. So you can write that as 1 over 4 over 13. So 4x is 184 over 13. Then divide by 4. 184 divided by 4 is 46. So 46 over 13. This one's a little messy. Don't let that bother you. It's the idea on the additional elimination that's really critical, not the messiness of the details here. So as an ordered pair, it's this. This one's a little tougher to check because it's kind of messy. But if you plug it into the original system, it should be true. All right, let's move to, I think I'm going to jump down to maybe number 5b. So these are some word problems, and 5b is a mixture problem. So you have one solution containing 20% alcohol mixed with another containing 60%. Your final product will be 10 gallons of 32% alcohol. And the question is, how much of each should be used? Okay, so early on, you want to do two things. Early on, you want to draw a picture. And early on, you want to identify and label all the unknowns. Normally, I would label the unknowns first and the picture maybe second. But because of my setup, I think it's going to be easier for me to do the picture first. So I don't have to keep switching back and forth between this and the PDF. So I'm just going to draw a couple solutions, and then we're going to combine those to get this bigger solution. We're told that one of the solutions is 20% alcohol. We'll say it's this one. And the other one is 60% alcohol. And the final product is supposed to be 32% alcohol. And we're told that the final product is 10 gallons. And the question was, how many gallons of the 20% needs to be added to how many gallons of the 60% to get this final product? So early on in word problems, you always want to label anything that you don't know. And you want to do this somewhat clearly, if for no other reason than partial credit. So I don't know how much of the 20%, so let's call that X. So let X be the number of gallons of the 20% that we're mixing with the 60%. And then we also don't know the amount of the 60%, so I'm going to call that Y. Those are quotation marks. And I think I'll stick those in my picture too. So the picture's got all my information. So X gallons of 20% is mixed with Y gallons of 60% to get 10 gallons of 32%. The question is, what is X and Y? We have two unknowns, and so probably we need two equations to figure them out. And the picture really helps with that. Now, there's one obvious relationship. You take X gallons of this plus Y gallons of this. That's supposed to add up to 10. So the first equation is X plus Y is 10. That 10 gallons on the right comes from the X and the Y that you're mixing. So that's just looking at the total liquid and the fact they combine to be 10 gallons. The second one's a little bit trickier. We're going to track not the entire liquid, but just the alcohol. So pretend that you evaporate off, say, the water, and this is down to just the alcohol. And you do the same here. Evaporate the water off, so you just have the alcohol. Do that here. The idea behind the second equation will be the amount of alcohol in here plus the amount of alcohol in there will equal the amount over on the right, because everything on the right came from the left. Now, the amount of alcohol on the right, we can actually calculate that exactly. There's 10 gallons total. 32% of the 10 gallons is alcohol, and math of often means times. So 32% of the 10 gallons is pure alcohol. So 0.32, that's 32% if you write it as a decimal. Of is times. So 0.32 times 10 is the number of gallons on the right. And if you do the work there, that's 3.2 gallons. Basically, a third is alcohol. We had 10 gallons, about a third is alcohol. So there's 3.2 gallons of alcohol on the right. To find the number of gallons of alcohol in the first jar, you do the same kind of thing. You take the percentage and you multiply by the volume. 20% of the X gallons is alcohol. So 0.2 times X. 0.2 is 20% when you write it as a decimal. 20% of, or times, the total volume X is the amount of alcohol there. And then for the second one, it's 0.6 times Y. And the alcohol from the first jar plus the alcohol from the second jar equals the alcohol on the right. So the system, cleaning it up slightly, is X plus Y equals 10. And then we have 0.2x plus 0.6y equals 3.2. So this is my linear system of two equations, two unknowns. I could use substitution, I could do additional elimination, I could maybe even try to do it graphically, though that'd be kind of hard. I'm going to do additional elimination. I'm going to try to make either the x's or y's opposite. Now I don't like this bottom equation because of all the decimals, so I'm going to multiply both sides by 10. This is for convenience. It's often good to get rid of decimals, it just makes life easier. When you multiply by 10, decimal places move one to the right. So we get 2x instead of 0.2x plus 6y equals 32. Now I'm trying to get either x or y to be opposite, so let's maybe make the x opposite. I already have a 2x in my second equation, so maybe I should take the top equation and multiply both sides by -2. Then we get minus 2x, minus 2y, and minus 20. And now I can just add these up. The x's go away, that was the point. There's a total of 4 y's. 32 minus the 20 is 12. And now it's easy to get the y alone, just divide by 4. So y is 3. And then remember, x plus y is 10. There's 10 gallons total. So obviously, if y is 3, x is going to be 7. Then it's good to write the answer in words. X is the number of gallons of 20%. So 7 gallons of 20%. And y was the number of gallons of 60, so 3 gallons of 60. Okay, that adds up to 10, so that part at least is right. And you can kind of estimate if that sounds reasonable. We're mixing 20 and 60 to get 32. If you were to add equal amounts of 20 and 60, if you did an equal amount of this and an equal amount of that, you'd expect to get the average concentration, which is 40%. We're after something weaker than that. So I would expect we should have more of the 20 and less of the 60, because the final product should be on the weaker side compared to the average. I'd expect x to be a little bit more than 5. So 7 might be right. I can't tell if it's exactly right, but that might be right. Okay, let's jump to 8. Now that has a lot of parts to it. I'm going to go right to Desmos, I think. So first one is 2x plus y less than or equal to 4. Oops, wrong one. So let me start with equals 2x plus y equals 4. That's a line. And you can easily get this graph by doing intercepts. If you let y be 0, you'll find out that x is 2. You'll get this point here. And if you let x be 0, you get y is 4. You'll get that y-intercept there. And then you connect the dots. So that's the graph for the equation, 2x plus y equals 4. But we want the inequality, 2x plus y less than or equal to 4. So that means you want the line, but you also want a shade on one side. Let me write this on the other page. So we're doing 2x plus y less than or equal to 4. We already graphed the line, and then I'm trying to decide which side to shade on. I can either shade below the line or I can shade above the line. What I like to do is, unless the origin's on the line, I like to test the origin. Let's see where the origin is. So the origin's that blue dot. I'm either going to shade on the blue dot side of the line or the opposite of the blue dot side. So the way you can tell which side you want is you plug in the test point. I'm using the origin. So plug in x equals 0, plug in y equals 0. Because I just picked that random point. Just pick something on either side of the line. And normally the origin is one of the best places to pick. Unless it's on the line, then pick something else. and then see what happens. You get twice 0, because x was 0, plus 0, less or equal to 4. That says 0 is less than or equal to 4. That's true. When you do the graph, you're shading the stuff in that makes the inequality true. So I want to shade in all the ordered pairs to make this true. I now know that 0, 0 makes this true. So the origin makes it true. So on this line, you want to shade the origin for sure, and then all the stuff on the origin side you want to shade. So with Desmos, you'll see it looks like that. So that's the graph. It's the line plus we've shaded on one side. Then the other one is 2x minus 3y less than or equal to 6. 2x minus 3y less than or equal to 6. You first would draw the line, you get intercepts. So if you let y be 0, you'll see x is 3. And if you let x be 0, you'll see that y is minus 2. So if you're just graphing the line part, it was 2x minus 3y equals 6. It's right there. There's the x-intercept of 3. There's the y-intercept of minus 2. But again, we want to shade on one of the sides because there's an inequality. I just did the graph when it was equals, but it might be less than. So notice the origin's not on the green line. So let's see if we want to shade on the origin side or the other side. So once again, I'm going to just plug these in, see what happens. You get twice 0 minus triple 0 less than or equal to 6. So 0 is less than or equal to 6. That's true. So the origin should be shaded in. So you want to shade in on the origin side. So this becomes less than or equal to. So notice we're shading above. And then we're looking for the region that's been double shaded. In Desmos, there's kind of a nice way to do this, though it's maybe hard to remember. First of all, notice I can click on this circle on the left and turn it off. By clicking on it, I can turn it on or off. So I'm looking for the stuff double shaded. But to see that better, I'm going to go up to the top one, and next to it I'll put in a set bracket. And that set bracket is saying limit the previous graph. Then I'm going to copy in what I just wrote, and then close the set bracket. So now you can see the region that has been shaded twice. But we're not done, because we also want x to be bigger than or equal to 0. X equals 0, it's just the y-axis. It's in orange here. But we have to color on one of the sides. Now this time you don't want to use the origin, because the origin actually is on the orange line. So you pick something maybe to the right or to the left of the origin. So let's see, x, we're doing x bigger than or equal to 0. So maybe pick the point 1, 0. Because that's to the right of that. So here's the x equals 0 line. Here's my point I'm picking. Stick in 1 for x, stick in 0 for y. There are no y's, so you don't have to worry about sticking in for the y. But put in for the x, and then you get 1's bigger than 0. That's true. So you want to shade on the right. With x bigger than or equal to 0, you shade on the right. So going back to Desmos, you can see we're shading to the right, and then I want to include that in my restriction. So I'm going to first turn it off here, go up here, include it in set brackets. So I've restricted it even more, but we're still not done, because we also have y bigger than or equal to 0. Y equals 0 is the x-axis, and obviously this is the stuff above it. I'll show you separately. Looks like that purple region. Let's turn that off. I'm going to stick it at the end of all this stuff. Set bracket. Okay, so that's it. That's all the regions combined. It's this region right in here. These intercepts came from one of the lines. We're in the right upper corner, the first quadrant, because of those bottom two inequalities. And so with these multiple inequalities, you just put them in one at a time and you look for the region that's been multiply shaded, in this case shaded 4 times. So basically, we get rid of this again. Should have cut that out. There we go. Put that back in. So you're looking for the region that's been shaded in 4 times, and that's that triangle region. It's hard to tell, that's why I did it the other way. But that triangle region's been shaded 4 times. Okay, let's look at 9b. I'm supposed to determine the domain and range of the following relation and also see if it's a function. Okay, so 9b. If I can get my pen to work. I had this trouble earlier. Oh, there we go. Okay, let's see. Yeah, wait. Okay, sorry, I had technical difficulties. My recording just totally stopped. I think I'm back on track. So I was doing 9b, and we're trying to identify whether this is a function or not, and also identify domain and range. Okay, with the part of the function, basically the idea is each of these ordered pairs represents an input and an output. First number is the input to the function, and the second is the output. It's kind of like a machine. I feed the machine -2, it spits out 7. Feed the machine 0, spits out 1. Feed the machine 3, spits out -1. Feed the machine 3, spits out 2. You have a function if you never get different outputs for the same input. It's kind of like a Coke machine. You don't want to stick money in, at least not as the manufacturer, and have 2 different sodas come out. One thing in, you want one thing out. You don't want different things out. Like a calculator, you ask it what's 1 + 1, you don't want it giving you 10 different answers. You want a single answer out. Notice here, when I feed this a 3, it tells me it's spitting out -1. But it also tells me when I feed it a 3, it's spitting out 2. So an input of 3 is being taken to -1. That's fine. But then here's the problem. It's also being taken to 2. Functions don't do that. A single input doesn't go to multiple outputs. It's okay to have different inputs go to the same output. Something like this would be okay. If 1 got taken to 7 and 2 got taken to 7, that's fine. But you don't want one thing splitting and going to multiple places. So because 3 gets shot to 2 different things, it's not a function. So that's one of the questions. And then the other is domain. That's fairly easy. That's the set of inputs, which means it's the set of the first numbers. So you just look at all the first numbers. So you have a -2, you have a 0, you have a 3, you have another 3, but with sets you don't put in repeats. It's not wrong, it's just not good form. So all the distinct inputs, all the distinct first numbers, that's the domain. And the range is the set of the outputs. And again, don't put in any repeats if you had any. So you look at the second numbers, 7, 1, -1, 2. Order doesn't matter. I would either do the order that they're listed or maybe put them in increasing order. With sets, order doesn't matter. So that's domain and range for 9b. Okay, let's move to 10. Here we have a formula for a function. We're asked to evaluate first at -4. That's fairly simple. And then we're asked to evaluate at a + 2. Copy that. So 10. The function is h of x equals -3x squared plus 4x minus 7. Part A is evaluate h at -4. So that means you want to plug in -4 for all the x's. Now this can get tricky. It won't be so tricky on part A. It gets trickier on part B. What I would suggest is you either literally write what I'm about to write or at least think what I'm about to write. Instead of writing h of x as negative 3x squared plus 4x minus 7, write or think h of blank is minus 3 times blank squared plus 4 times blank minus 7. The idea behind the function is you're feeding it something, whatever goes in the blanks. It's going to square that thing, multiply by minus 3, then add 4 times whatever you feed it, subtract 7. So I would suggest you replace the x's with blank parentheses, because then all you have to do is just fill in these blanks with whatever the input is. And if you do this, it's very safe. You won't make a mistake on the setup. So this is negative 3 times the quantity. You need these parentheses here because the entire negative and 4 together are squared. Not just the 4, but the negative there is getting squared too. So that'll turn into a plus. Now because of this, it'll end up being minus. But that inner minus there gets destroyed by this square. Plus 4 times minus 4. Minus 7. So you do the square. That's negative 4 times negative 4. That's 16. But that's still times the negative 3. And then this product here is a minus 16. Minus 7. So we have minus 48. That's the negative 3 times the 16 part. And then we have a minus 23 if you combine the other two here. And then you add those up. That's minus 71. So that part's fairly straightforward. You're just sticking in a number, and so it's not that bad. But part B is a little bit tougher, as you're putting in this expression, a plus 2. So part B, evaluate h at a plus 2. If you do the blank parenthesis thing, this is dangerous switching to eraser, but I'll try. Oop, erased too much. Erased a little more than I wanted, but it's okay. Let's go back to black. So h blank, this is parentheses there. Now you just fill those in with a plus 2. So h of a plus 2 is minus 3 times a plus 2 quantity squared. You need those parentheses. You also need them here. So not putting in the parentheses when you need them is a common mistake. And if you do this blank parentheses stuff, you're less likely to make that mistake. So negative 3 times whatever the input is squared. Here it's a plus 2 squared plus 4 times the input. That's the entire input. 4 is not just times the a, but also times the 2, minus 7. And then you do the algebra. Now be careful on the a plus 2 squared part. The most common mistake that students make in algebra is to think you can square them separate. It doesn't work that way. This is not a squared plus 4. It'd be nice if that were true, but it isn't. You have to FOIL this. You have to take a plus 2 times a plus 2, because that's what the square means. Then you do FOIL. Do the first product, outer product, inner product, last product. So if you do that, down here we have our negative 3. And then with the FOIL, the a times a is a squared. Outer product is a times 2, which is 2a. Inner product is a times 2, which is 2a. Add those up, you get 4a. So that's outer plus inner combined. Last product is 2 times 2, which is 4. And I guess I'll save this other stuff for the next step. Okay, then we have to do some distributing because we have some parentheses around. So I'm going to take the negative 3, separately multiply by each of those terms, and take the 4, separately multiply. Minus 3 times a squared is minus 3a squared. Minus 3 times 4a is minus 12a. Minus 3 times 4 is minus 12. 4 times a is 4a. 4 times 2 is 8. Then you still have the minus 7. So we have the negative 3a squared. That's the only squared term. So I've accounted for that. there's a debt of 12 A's, then you get 4, so now you're just in debt by 8 of those A's. And then this 8 minus 7 is 1, and add that to the negative 11. I'm sorry, the negative 12, you get negative 11. So that is the simplified output of this function. Okay, let's do 11a. I think this will be my last one. So it wants us, it's kind of like the one we did earlier with the ordered pairs, but this time it's with the graph. They want to know, is it a function? It's definitely a relation. Anything you can draw is a relation. Anything that an infant would draw on paper with a crayon is a relation. The question is it a function? And then what's the domain and the range? So let me start by re-entering that on Desmos, if I can find it. There we go. It turns out the equation for this, you don't need to know this. It turns out this is the equation. So this should match what we had. It's an ellipse. It's hitting at 3 and minus 3 on the x-axis and plus or minus 2 on the y. That, I think, matches what this is doing. You can tell pretty easily if it's a function by using the vertical line test. If you take vertical lines, let's start with x equals negative 4. And if the vertical line ever hits more than once, it is not a function. If the vertical lines hit once or less everywhere, it is a function. So this vertical line, things look good. It doesn't hit, that's fine. That just means I picked an x value that's not in the domain. I picked an input that this thing doesn't recognize. If you do x equals negative 3, that looks good. That's just hitting once. So far I'm thinking it's a function because I've drawn a couple vertical lines. It either didn't hit at all or it hit once. That's great. But then if you do something like x equals minus 2, we got a problem. It's hitting twice. There's these 2 points of intersection there and there. If you can find just one vertical line that hits more than once, you're in trouble. Because this vertical line represents an input. It represents an input of minus 2. These 2 points tell you the corresponding outputs. You plug minus 2 into this thing, it's spitting out negative 1.491, and it's spitting out positive 1.491. So it's like you have one input, minus 2, it's going 2 different places. And functions don't do that. So it is not a function. And the reason is fails vertical line test. If you have a picture, you can just glance at it and you can tell whether you have a function based on this vertical line test. Okay, then the other question was, what's the domain and the range? You can think of the domain as the shadow this thing is going to cast on the x-axis. Or you can kind of think of it like smashing a bug when your hands come from above and below. You want to see where the guts would be on the x-axis. In this case, it looks like they're going to run from minus 3 to plus 3. So I'm going to do y equals 0. That's the x-axis. But restrict it between minus 3 and plus 3. So that orange line, that would be the shadow this would cast on the x-axis. That orange line segment, that would be the guts if you smash this bug onto the x-axis by slapping it from above and below. That's the domain. So the domain is this interval from minus 3 to plus 3. So domain you could do it in various forms. I'm going to use interval notation. So it's from negative 3 to plus 3. I can also write that in set notation. Let's see, in the answer, which one am I doing? I'm doing 11a. I had to give it an interval notation. Okay, now in the range, it's sort of similar. The range is the shadow on the y-axis. So now you're smashing the bugs from the sides, and you're trying to see where the guts are on the y-axis. So here's the y-axis. It's that purple line. But the part of it that comes from this ellipse would be the part between -2 and 2. So let me restrict it. So you can see that purple line segment. That would be the shadow that this ellipse would cast on the y-axis. That purple line segment would be the range. It would be the guts if you smashed this on the y-axis. So domain is just the shadow on the x-axis. The range is the shadow on the y. So it's the interval from -2 to 2. Again, you can write this in various ways. We're using interval notation. You can also do set notation. So with the picture, you can easily tell if it's a function to see if it passes the vertical line test, which this does not, so it's not a function. And from the picture, you can easily tell what the domain and range is. Domain is just the shadow on the x-axis. Range is just the shadow on the y-axis. So domain here is the orange line segment. The range is the purple line segment. Okay, sorry about the technical glitch I had in the middle, but I hope that was beneficial to you. Good luck on your test.